Together, Splunk and Palo Alto provide a rich set of functionality to help operators secure their enterprises. Today, we're going to discuss 3 use cases that highlight the potential of the Palo Alto Network's data and integration with Splunk. They are intended to give users new ideas and understandings so they can leverage the 2 technologies for their own security and operations. First, we will show how quickly a security investigation can be performed using the Palo Alto app and understanding of the Palo Alto logs. Second, we'll talk about taking action right from Splunk to limit the impact of incidents. And third, Splunk regularly updates security-relevant content for its customers. How can some of this content be applied to PAN log data? Let's jump in. This is the Palo Alto app for Splunk. The app includes dashboards and search drill downs for every domain Palo Alto products cover. They can be used by security operators and IT administrators to increase visibility across their environment. Imagine that we receive an alert from Palo Alto Traps that it stopped a process for an endpoint. We can see sample.exe was stopped, and if we look at the latest blocked executables, we can see that it belongs to the user Martok. At this point, we want to know if Martok is the only one with this issue, or whether there are others. We will have to understand the overall impact. Maybe the threat has expanded to others. Maybe it's isolated. Either way, we have cleanup to do, and we need to know how much. Let's click on Martok. Most dashboards are built with drill downs into the other data. This takes us directly to the actual traps logs corresponding to the prevention event. If I see here, I have one source type, and it's a prevention event from the Palo Alto Traps product. I know that once Traps finds an issue with an executable on an endpoint, it can submit the executable to Wildfire. Let's expand the search to see if there is a Wildfire report for these executables. First, we'll jump into one of the prevention events. An easy way to find the Wildfire event would be to search for the hash of the file across all data. And notice that I have 2 source types at this point, including the Wildfire log. If I expand this, I can see some of the indicators of compromise that Wildfire provides. If I scroll down a little further, I see that this might be related to WannaCrypt or WannaCry ransomware. If I want to know more about the malware than Wildfire is showing me, the app makes this easy for me. I can click on an event action, which will allow me to launch into autofocus. If I'm an autofocus user, this will cross-launch me to autofocus, where I can learn more about the indicators of compromise and perhaps ways to remediate. From autofocus, I'm able to cross-launch back to Splunk, so I can remain in my same seat and get a full view of the incident. So now I know I have potentially a larger problem. I'm especially happy I used Traps. Though I have a nasty issue on my hands, at least the whole disk didn't get encrypted. But again, I still need to take care of the problem. If I'm lucky, I'll make it home early. Now I need to know who else might be exposed, even if they aren't fully infected. The best way to find out who else might be at risk is to search all endpoint traffic across all the IPs and ports in the Wildfire report. If you're familiar with Splunk Search, this isn't too difficult to do, but it would take a little bit of time. Fortunately, the app has already thought of this. Let's look at the Wildfire dashboard in the Palo Alto app to see if it can help. The possible malware traffic table does exactly this search. Let's see what it includes. Here we see Martok, which is what we expect. And for one of the same ports, we also see TNG Moriarty. There you go. Another host has communicated with known bad destinations, but because we haven't seen Traps report for it, it probably is not fully infected. Thanks to the carefully thought out workflows and dashboards in this app, I have a pretty good idea that these are the only 2 endpoints that are affected. Let's go through scenario 2. The Palo Alto add-on implements a custom search command called PanTag. The command uses the XML API on Panorama or the firewall itself. It adds or removes tags, which can be incorporated into policies using dynamic address groups. The command allows you to apply firewall policy right from Splunk. Before showing how simple it is, note that it does not require a commit on the firewall, and policy and tag definition can be limited, so network security teams can limit the control if they would like to. It's possible to tag in order to increase log level for a session, issue a log by HTTP, block, allow, anything that can be done with a policy. Here we're going to quarantine these two infected hosts. It was that simple. Let's just take a quick look at the search to see how simple in fact it is. This essentially ends up with Moriarty and Martok as users and defines their source IP. In other words, the host they were using when they became infected in the earlier scenario. In order to tag them, I simply define which field the source IP is contained in, the name of the tag, which is captive portal, and the device to which I'm going to send it. And I'm going to add for an action. I can see based on the feedback that both were successfully tagged. This means that the next time they log in, their traffic will be redirected via captive portal, and they can be directed to come see IT to have their machines looked at. In a single command, I've taken a major step toward remediating the issue, and I still haven't left my seat. Finally, let's look at some other interesting things we can do with Splunk that enhance our visibility. As a leader in enterprise security, Splunk regularly updates content on top of our platform. Just one example of this is our Security Essentials apps. We recently expanded them specifically for ransomware. What we've done in this scenario is apply some of the search and correlation techniques shown in the Security Essentials app to Palo Alto logs. These searches use historic data to find recent anomalies. As an example, if we have a web server serving an internal app, we would expect its DNS usage to be pretty consistent. If I see a spike in DNS to outbound sites, that might indicate a problem. The analysis for this search was fed from Palo Alto traffic logs associated with the app DNS, and the analytics calculations are pulled directly from the Security Essentials apps. All of these assume the same basic technique, normal distribution of data for input. They use a threshold based on averages and standard deviations to figure out what the anomaly looks like. And finally, they categorize events into time ranges to see if the last time range shows an anomaly versus the earlier ones. They're meant to be run regularly, like every day or every week. In this scenario, we can see that the outlier is the host .90 and that it goes above the top threshold for this particular search. Overall, constructing these searches and diagrams is simple in Splunk. They're not easily done using other solutions. So there you have it. We've shown 3 use cases that highlight the power of Splunk and Palo Alto together.